This video is going to walk you through how to draw a unit circle, including labeling all of the degrees and radians and special angles all around the circle in units 1, 2, in quadrants 1, 2, 3, and 4, and to label the x and y values using the cosine and the sine values. So we'll start by drawing a circle. And we're going to draw an x-axis and a y-axis. And remember that when we talk about the unit circle, we talk about it on top of a coordinate axis system. So this is my x-axis, and this is my y-axis. And the first thing that and also remember that the center of the circle is the point 0, 0. The thing that makes a unit circle is that the radius of the circle is 1, and we'll come back to that in a little bit. The next thing that I want to do with my unit circle is label the angles in degrees. And so I'm going to start, I'm going to start over here by the x-axis where the unit circle intersects with the positive end of the x-axis. That point is 0 degrees. And up here, where the positive y-axis intersects with the unit circle, that's 90 degrees. Over here on the negative x-axis, that's 180 degrees. Down here, where the negative y-axis intersects with the unit circle, that's 270 degrees. And you want to come full circle, so you also want to label the same thing that you labeled 0 degrees, you want to label as 360 degrees. Also remember that you need to be able to give the radians for each of these. Although the degrees for each angle needs a degree symbol as a label, the radians won't use a unit. So 0 degrees is 0 radians, 90 degrees is going to be pi over 2 radians, 180 degrees is going to be pi radians, 270 degrees is going to be 3 pi over 2 radians, and 360 degrees is going to be 2 pi radians. Now, next, in each quadrant, we're going to have 45 degree angles, or the angle that would have a reference angle of 45 degrees. And the 45 degrees, remember, is approximately halfway between 0 and 90. And when you're drawing your unit circle, you can kind of just eyeball what your halfway is. And you should see that each one of those dotted lines that I just drew looks approximately halfway between the two quadrantal angles. And they also look like they're approximately 45 degrees from the x-axis, and that means that they each have a reference angle of 45 degrees. So we're going to label the quadrant 1 angle as 45 degrees, and the quadrant 2 angle as 135 degrees. Remember that 135 is 45 degrees away from 180, and we always talk about reference angles being away from the x-axis. The quadrant 3 angle that we just drew is going to be 225 degrees, and the quadrant 4 is going to be 315 degrees. And then we want to go back and we want to fill in the radians for each of those measures. Now, if you think of the top half of the circle, or from 0 to 180, as 4 pi over 4, so over here you're thinking four pi over 4, which of course is equal to just pi. If you think all the way around is 4 pi over 4, then this first fourth of the top half is going to be 1 pi over 4, or just pi over 4. The second fourth is 2 pi over 4. Well, if you think about that, 2 pi over 4 simplifies to pi over 2, and we already said that that was 90 degrees. So we don't need to write that one in. But we have 1 pi over 4 and 2 pi over 4. Now if you go another fourth, that's going to give you 3 pi over 4. And that's the clock on the wall in the background. The fourth then gets you to the 4 pi over 4 that we talked about a minute ago. Now, as you keep going around then, you keep increasing the numerator by 1. So the next one, we've done 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and this next one here is going to be 5 pi over 4. If you go another fourth of the way around, this one would be like 6 pi over 4, but if you simplify that fraction, you get 3 pi over 2, and we already have 3 pi over 2 for 270 degrees. So that was 6 pi over 4. This next one will be 7 pi over 4. And then that last one, that last turn, you're thinking is that it would be 8 pi over 4, but 8 over 4 reduces to just 2 pi. And we've already got 2 pi, so that's your thinking there, but you don't need to write it. So now we've got 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. We've got all of our 45-degree angles, the radian measures of each of those angles. I'm going to erase some of these arrows that are inside of my unit circle so that it's nice and neat, so that we can move on to the 30 and 60 degree angles. And we're going to do the 30s and the 60s at the same time. And so if you want to go ahead and start drawing them while I'm erasing. Okay, so if you imagine each quadrant being divided into basically 3 parts, 0, 30, 60, 90, they would be approximately there and there. Now, let's start with just the 30-degree reference angles. If you are now in the second quadrant and you have an angle whose reference angle is 30 degrees, that angle is going to be 180 minus 30, and that'll be 150 degrees. If you have an angle in the second quadrant whose reference angle is 60 degrees, I know I said that I would stick with the 30s, but I want to finish the second quadrant. That's going to be 120 degrees, because 120 is 60 degrees away from 180. So there's your second quadrant degree measures. And let's look at the third quadrant. Yes, I'm drinking coffee while I'm making videos. And this degree measure is 30 degrees away from 180, but it's 180 plus 30 this time, so it'll be 210. And the angle that has a reference angle of 60 degrees in the third quadrant is 180 plus 60, and so that's going to be 240 degrees. So there's your third quadrant angles. And then your fourth quadrant angles, the one that has the reference angle of 30 is going to be, I don't like that one. The one that is going to be 30 degrees is going to be 360 minus 30, because you always want to measure to the x-axis for the reference angles. So that's 330. And then the one that has a reference angle of 60 degrees is approximately here. And that one is 360 minus 60, because the reference angle is measured to the x-axis. And so that's going to be 300 degrees. So now you have all your degree measures written in for all of your angles, all the quadrantal angles, and all of the 30, 45, and 60 degree angles in each quadrant. I'm going to erase just a little bit of the scribbly stuff that I've written so far with the simplifying fractions, so that I have a little bit more space to write. And we will fill in the radians for each of those angles. Now, I want to kind of do the same process that I did when I was looking at the fourths. I'm going to start with the 30 degrees, and 30 degrees is 1/6 of 180. So if 30 degrees is pi over 6, and that's because 180 is pi, and 30 times 6 is 180, so 30 degrees is pi divided by 6. 60 degrees is twice 30. So if you think here for 60 degrees, think 2 pi over 6, and that simplifies to just pi over 3. Your 60 degree angle is pi over 3. So in the first quadrant, you've got pi over 6, pi over 4, and pi over 3. But remember that we can count these off, because 30, 60, 90, 120, 150, 180 should be 1, 2, 3, 4, 5, 6 sixths. So 30 is pi over 6, 1 pi over 6. 60 is 2 pi over 6. 90, think about this as 3 pi over 6. 3 pi over 6 simplifies to 1 pi over 2, which we already have. And then 120 is going to be 4 pi over 6. 4 pi over 6 can be simplified. 4 pi over 6 then simplifies to 2 pi over 3. So 120 degrees is 2 pi over 3. 150, so we've got, I'm going to back up a bit. 30 is 1 pi over 6, 60 is 2 pi over 6, 90 is 3 pi over 6, 120 is 4 pi over 6, 150 is 5 pi over 6, and 5 pi over 6 cannot be simplified. So 5 over 6 is a fraction that can't be simplified. And then 180 would be 6 pi over 6. That's what your thinking is, but the 6's simplify and give you just pi, which is what you wanted 180 to be. Now, as you look at the 30 and 60 degree angles going the rest of the way around the circle, you'll find that the 210 is 7 pi over 6. 240, remember that your thinking is 8 pi over 6, and that simplifies to 4 pi over 3. So 240 is 4 pi over 3. I didn't erase this one from the 4s. And then your 270 is going to be 9 pi over 6. And so 9 pi over 6 simplifies to 3 pi over 2, which we already had. 300 then would be 10 pi over 6. And again, 10 pi over 6 can be simplified to 5 pi over 3. And so 300 is 5 pi over 3. I'm circling the ones that I want to erase later. That's 10 pi over 6. Then the 330 is 11 pi over 6, and 11 over 6 cannot be simplified. And again, if you think about going all the way to 360, 12 pi over 6 simplifies to just 2 pi, which we know is 360. So 1 pi over 6, 2 pi over 6, 3 pi over 6 is 90, 4 pi over 6 reduces to 2 pi over 3, 5 pi over 6 can't be simplified, 6 pi over 6 is 180 or just pi, 7 pi over 6, 8 pi over 6 becomes 4 pi over 3, and that's 240. 3 pi over 2 is the same as 9 pi over 6. 10 pi over 6 becomes 5 pi over 3. 11 pi over 6 cannot be simplified, and 12 pi over 6 is the same as just 2 pi. So again, I'm going to do some erasing here. I'm going to leave just the completely simplified fractions, I hope. Now we need to add another thing to our unit circle, and that's the x and y values of each of these points. So each point should have an x and y value. I'm having trouble zooming in. Each of these points should have an x and y value that is representative of the sine and cosine of that angle. So remember that on a unit circle, the x value is the cosine of the theta, and the y value is the sine of the theta. So for example, if you look at 0, 90, 180, 270, and 360, those are called quadrantal angles. And the point value, because it's a unit circle and a unit circle has a radius of 1, the point value of that point right there is 1, 0. That means that the sine of 0 is 0 and the cosine of 0 is 1. The sine of 360 is 0 and the cosine of 360 is 1. At 90, the point is 0, 1. At 180, the value is -1, 0. And at 270, the point is 0, -1. Now we're going to do that same thing for each of the 30, 45, and 60 degree angles in each quadrant. I think I'm going to switch over to black so that you can see it amidst all those colors that I have written all over the place. And so start asking yourself, do you know the angle values for 30, 45, and 60, the sine and cosine values of 30, 45, and 60? And if you don't, grab your chart. Remember that those are the three that you want to have learned. So the cosine of 60 is radical 3 over 2, and the sine of I'm sorry, the cosine of 30 is radical 3 over 2, and the sine of 30 is 1 over 2. The cosine of 45 is radical 2 over 2, and the sine of 45 is radical 2 over 2 as well. And the cosine of 60 is 1 over 2, and the sine of 60 is radical 3 over 2. And each of those ordered pairs represents the x and y values of the coordinates of the point that's on the unit circle that would make that triangle. But then what I want you to keep in mind is that all of this unit circle has symmetry. And so if you were to draw, they talk about it like a bow tie. If you were to draw, let's say, a bow tie with all of the angles, let's start with the 30, all of the angles that have a 30-degree reference angle, they should all have the same x and y coordinates with just different signs based on the quadrant. So for example, in quadrant 2, all of your x values are negative and all of your y values are positive. So when you get into quadrant 2, you're still going to use the radical 3 over 2 and the 1 over 2 for the 150, but the thing that's going to change is that you are going to make the x value negative. So it's going to be negative radical 3 over 2 and positive 1/2. So that's the coordinate ordered pair for that point at 150. Now, the point that's at 210, right here, in the third quadrant, every x and every y value has a negative value. So this is going to be negative radical 3 over 2 and negative 1/2. And then in the fourth quadrant, the angle that has a reference angle of 30 is going to end up having a negative y value, but a positive x value. So positive radical 3 over 2 and negative 1/2. Now, those are your values, cosine and cosine, for the angles that have a reference angle of 30. Let's next do the angles that have a reference angle of 45. And so again, you can think of this like a bow tie. And all four of these angles should have the same x and y values with different signs, different positive and negative signs. This one's easy because both sine and cosine of 45 is radical 2 over 2. And so all you need to do is think about the signs. So in quadrant 2, this is going to be negative radical 2 over 2 and positive radical 2 over 2. That's the coordinates for this 135. In the third quadrant, the coordinates for 225 are going to be both negative, negative radical 2 over 2 and negative radical 2 over 2. And then in the fourth quadrant, when we look at the 315, the coordinates of that point are going to be positive radical 2 over 2 for the x value and negative radical 2 over 2 for the y value. And again, those 4 points are the ones that have a reference angle of 45 degrees. And last but not least, we're going to fill in the ones for the angles that have a reference angle of 60. And so I guess I'm going to have to use red here for my bow tie. And we want to hit these 4 points right here. And so these points are all going to have an x value that's either positive or negative 1/2 and a y value that's either positive or negative radical 3 over 2. So in the second quadrant, it's going to be negative 1/2 and positive radical 3 over 2. In the third quadrant, both are going to be negative, so it's going to be negative 1/2 and negative radical 3 over 2. And in the fourth quadrant, the 300-degree angle is going to be positive 1/2 and negative radical 3 over 2. And those are the 4 points that have a reference angle of 60 degrees. And there you have your fully labeled unit circle.